Hi, welcome back to Byte Forever. Bit of a celebration is in order at the moment. So this Z80 homebrew computer that I've been building, based on a design by Bread80, couch to 64K, I think the blog was called. He's actually building on a breadboard, so I took the extra step. Built it on a PCB. Probably seen some of the short video updates I've been doing. I'll probably just give you a quick explanation of what we've got. My PCB or my circuit is different to Bread 80s in that he's got quite a neat, actually, a neat way of allowing for banking of RAM, and switching out the ROM, so you can eventually run CPM. Whereas I've gone for a simpler design where I've got lower 32K is the ROM, so the CPU boots off that, and then the upper 32K is just that SRAM chip there. I did make a little error in the PCB where I had two chips. There's actually meant to be one there, but that hasn't arrived yet. That's for the keypad, or one side of the keypad interface, and that's actually duplicate location. All the pins to sort of duplicated. I might be able to use that for something eventually, as we've got another set of I/O, but the address decoding logic won't work for that, I don't think. Anyway, yeah, so bit of explanation. That's a Z80. You've probably seen this CPU, the same one, in some of the breadboard videos that I did. We've got a heatsink on top, but it doesn't actually need it, I don't think, but because that's not even warm at all. It is a little bit. That's the EEPROM, and then the SRAM. Got an LCD display, crystal reset button, just a power LED, power connectors down here. These two chips are 74LS00, 2-input quad NAND gates. I think that's a 138, 74LS138 for address decoding, and I think that's LS32. You can see that, yeah. Which is I think it's an OR gates, or multiple OR gates on the same chip. So yeah, what I've got is some code which initializes the LCD, and because now I've got RAM, I can actually use call and return in the code, and I've got a stack set up, and so I'm printing out. There you go, Z80 byte forever, and just a really simple mem check, which essentially, I'll show you the code in a second. It really just writes 1 byte to the RAM and then reads that same location back. I'll just show you that now. So as for some of the other videos, this code's on GitHub. Try and put a link in the description. The first bit of it initializes the LCD using a list of commands, which is quite cool now because you need to do a delay. So when you actually send the command to LCD, you have to wait for it to respond. It's got like a busy flag on one of its registers. Previous code I had, I couldn't use because I didn't have the RAM working. I couldn't use call and return, but now I've actually got proper subroutines working, which is cool. Print out the boot message, and then at the bottom, just like I said, it just says 55, but because I'm only displaying one character, that kind of got garbled a bit when you add the ASCII for 0 to it, the actual alphanumeric 0. But anyway, yeah, so writing a 5 to stack bottom, which is defined in the hash define at the top. I'll just show you that in a second, and then reading back from that same location and then printing it on the LCD, and it's actually printed 5, I think you saw earlier on the LCD, and yeah, there's just some variables. I'm actually writing a simple monitor at the moment. I haven't got very far, but that's why I've got some like system variables. A lot of this is kind of similar to what you'd see in the ZX81. Obviously, quite a bit different because the memory addressing is different. I've got like quite a small stack actually, but it doesn't need much at the moment. I might make that bigger later. But yeah, so yeah, I'm quite pleased with that now. I wasn't sure halfway through this if I turn this over. Well, I'll just pause the video and then switch it off and then turn it over. Actually, it should be robust enough to cope with that. Um, seeing as it's not like a breadboard with loads of wires everywhere like it was before. Yeah, I did make a mistake in the logic on the PCB. I got it wrong, but I've sort of got a few little problem fixes there. So full disclosure, had to cut a few of the tracks on the back and then sort of solder some links across, but tried to make it reasonably neat. Hopefully now I've proved that that logic works, we can update the schematic and maybe add some more components to PCB. Probably wait a while for that because I want to get the keypad working as well, which eventually sort of solders into there. There's like a keyboard scan and sort of output. You actually have to output to a buffer and then scan it back through a latch, I think it is. Anyway, thanks for watching that quick update video. Oh, turn it back round. It's still there. Thanks for watching, and bye for now.